Far from land and deep below the bottom of the ocean, people are exploring an undiscovered realm of water, rock, heat, and life within the ocean crust. Boreholes drilled for scientific discovery, sampling, and experiments penetrate farther than 2 kilometers, 20 football fields, below the seafloor. Some of these boreholes are sealed to create long-term subseafloor observatories called CORKs. A CORK is a system of hardware, plumbing, seals, and scientific instruments. CORKs allow scientists to measure and sample pressures, temperatures, fluids, and microbial life. Researchers use these samples and data to learn how processes occurring in the ocean crust below the seafloor impact the oceans and the rest of our planet. Before a CORK can be installed, the borehole needs to be prepared by installing a reentry cone, a big funnel, and casing, large pieces of pipe that help to keep the hole open. Different casing diameters, lengths, and materials are used depending on the environment and experimental goals. The CORK is sealed in place with cement, inflatable packers, and rubber rings to isolate it from the overlying ocean. This allows formation conditions around the borehole to return to their pre-drilling state. The upper ocean crust is the largest aquifer on Earth, holding as much water as all the ice caps and glaciers on the planet. This is mostly salt water, not fresh water, but like fresh water on land, the salt water below the seafloor is in motion, moving from place to place across vast distances. CORKs are used for many purposes, and their design is flexible so that new experiments can be run over many years. The part of the CORK that extends above the seafloor is called the wellhead. The wellhead is divided into 3 sections called bays. Each of the bays contains the ends of long tubes that run from the wellhead down through the seafloor seal and deep into the borehole. These tubes connect to instruments and sampling points at different depths, allowing researchers to access these intervals over time to collect data and samples. A pressure bay contains highly sensitive gauges, batteries, and a computer that makes measurements and stores data for up to 6 years. The long-term fluid sampling bay contains samplers that collect fluids from depth using an osmotic pump, storing the samples in thin tubes for years until they can be recovered and analyzed on shore. Another bay contains sampling valves for collection of microbial material from the crust below, and in some CORKs contains a large ball valve used for a free-flow experiment. There are additional instruments hung on a cable that extends all the way from the top of the wellhead to the bottom of the CORK installation, hundreds of meters below the seafloor. The cabled instruments include temperature loggers, fluid samplers, and microbial colonization experiments to determine what kinds of microbes live where in the seafloor, how quickly they grow, and what they like to eat. Some CORKs have a large ball valve installed in the wellhead. This valve can be opened by a submersible or remotely operated vehicle, or ROV, to allow fluids to flow from the seafloor into the ocean. This allows sampling of these fluids and causes a change in pressure at depth that can be measured in nearby CORKs, helping to determine the large-scale properties of the ocean crust. CORKs are designed to last for 10 years or more. As old instruments are recovered from inside a CORK and from the wellhead, new and different instruments can be deployed. The instruments on some CORKs will be connected to fiber optic cables so that subsea floor data can be collected from land without having to go to sea. Long-term subsea floor observatories are transforming our understanding of conditions deep below the bottom of the ocean. Through monitoring and experiments, we can learn how microorganisms may have developed on Earth and how they could have developed on other planets, how the hydrologic cycle extends from continents to the seafloor, and how carbon is transported and might be stored within deep reservoirs. CORKs are opening a window into a vast and hidden realm of crustal rocks, flowing fluids, and life.